the first question there that you mentioned. Get this into the bigger view. I've got the wrong color pen. There we go. So average rate of change. This is a formula. This is f of b minus f of a over b minus a. It looks a lot like the slope formula.
Mm-hmm.
So your a is 0. Your a equals 0. Your b equals 3. And your f of x is the square root of x plus 1. So we need to
all those in. You just plug all those in, basically.
Yeah, we need to find f of 0. That's the square root of 0 plus 1. And then f of 3, which is the square root of 3 plus 1. So this is the square root of 1. This is the square root of 4. So that's 1 and 2. So for your particular problem, the average rate of change is f of 3 minus f of 0 over 3 minus 0.
Okay.
So that's 2 minus 1. Those two numbers there over 3 minus 0, which is 1/3.
Okay. So D. Okay.
Yes. As always, would you like another one like this, or would you like to just move to the next question?
No, I think we can just move to the next one. That was pretty straightforward.
Okay. All right. Number 2. Number 2 here. All right. Which of the following statements is false for the function? So that whenever you get something like this, you got to look at all of them, which is tough. But that we'll just look at them one at a time and see if they're true or false. Test prep stuff you might start at the end because the idea is to go all the way through them and get to the end. But we'll just go through them. So let's find the limit. So part A is the limit as x approaches 4. So part A is the limit as x approaches 4. So this is based on the following. You have to find that whether the limit as x approaches 4 from the left equals the limit as x approaches 4 from the right. Okay, so right here, this one is good for from the left because it goes up to 4 but doesn't include 4. And then this third one is 4 from the right because it's bigger than 4.
Mm-hmm.
Okay, so the limit as x approaches 4 from the left, f of x is equal to 3/4 times 4. You're taking this one up here and you're putting 4 in.
Right.
And that's 3. Then we got to check and see if the limit as x approaches 4 from the right, f of x, which is minus x plus 7, but so it's minus 4 plus 7. That also equals 3. So since these are the same, we can say that that's true.
Okay.
I'm going to do B up here to the right. Well, no, actually, let me not do that. So B is down here. B is asking about f of 4. So the function is the function defined at 4. So I'll snip that part in again.
So where did you get, how did you know to do the one with 3/4 and the one with the negative x plus 7? How did you know to do those two?
It comes from the domain over here. This one is good less than 4, and this one is good bigger than 4.
Oh, I see. Okay.
If you had a picture, the 0 to 4, it would look see up 3 or 4. It would look something like that graphically.
Right.
And then the other one does something like that. Actually, it's filled in. So they actually approach the same value for you to graph it. That's how you know.
Okay.
Okay, so f of 4, according to this thing here, it's asking when x is 4, y is 2. And since it's a value, it exists. Okay, so going back to our original f of 4 exists, that's true.
Okay.
So C is like A, except you're a different number, so you're using different parts of this. Okay, so let me snip part C in. The limit as x approaches 6, f of x exists. That means we have to find the limit as x approaches 6 from the left. And is that equal to the limit as x approaches 6 from the right? So this one works for from the left, I guess I'll say. And this one right here works from the right.
Okay.
So the work here is to use those. So the limit as x approaches 6 from the left, we're using this minus x plus 7. I'll just put that up there. So this equals of f of x. This equals. Let me put this over. This equals minus 6 plus 7, which is 1. And then the limit as x approaches 6 from the right, f of x, we're using the 1. So this equals the 1, whatever it is there.
Mhm.
These are the same. So that is also true. If they're the same value, they're true.
Okay.
All right, so now the limit as x approaches 8 from the left. Let's grab that. Let's talk about that one. In a real testing situation, you wouldn't want to do it this way. This is very slow, but it's good to understand the what we're actually doing in each step. But time is always kind of working against you. So this is 8 from the left. 8 from the left. So basically that means it's less than 8, somewhere that's less than 8, and that's this one down here. And the truth is that one-sided limits, which is from the left or from the right, they always exist. So a one-sided limit always exists. So you don't even have to find it. You can just say that it's true because a one-sided limit always exists. It approaches the value of 1, though, if that were the case.
All right, that makes sense.
Okay, so now for the last one, for part E, f is continuous at x equals 4. We probably should have done that after A. This graph over here, this is meant to represent the origin. 3/4 x is this right here, and then this part is the minus x plus 7. Okay, but at
Wait, wouldn't minus x plus 7 be going down because it's a negative slope?
it is. That's this part that right here. It's going down.
Oh, I see. Okay.
Okay, but at 4, I'm sorry, when x is 4, 1, 2, 3, 4, the y value is 2.
Okay.
3, 3. Oh yeah, 2. Sorry, 2. So it's filled in there. Okay. So there's a hole here. This is a hole. And that means it's not continuous because you can't draw it without lifting up your pencil. So that's why E is the false one there.
How do you know it's a hole?
Say that one more time.
How do you know it's a hole?
Because they're neither one are defined. See how this is at less than 4 and this is greater than 4.
Mhm.
There's not that line underneath.
Oh, okay.
It's a very small thing, but if you were to just graph it, you might see the intersection. Think, oh, these are okay, but they're not. Can't do that. Okay, that's a good question. You wouldn't. I would think you'd be asked, like, to me, it's like 5 questions basically. It's really A, B, C, D, and E. Like you have to do all
Right.
5 to
To get the
really,
answer.
yeah. So if any one of those is unclear, we should redo it. But that's that's it's up to you. All right, moving along to question number 3. Which of the following is an equation to the tangent line f of x equals 9 minus x squared at x equals 2? I'm going to ask, have you done the definition of the derivative, the limit as h goes to 0, f of x plus h minus f of
Yeah,
x
we've done that.
all over h? Okay. All right. So if you do this, that is the derivative. The derivative gives you the slope. So your f of x in this problem is 9 minus x squared, and then your f of x plus h is 9 minus x plus h squared.
Okay.
Hopefully you've seen that before now.
Yes.
So you have to be really good and fast now at like expanding things. So x squared plus 2xh plus h squared. And you have to be comfortable. It's even better if you can distribute in without writing it out.
I know. Yeah.
Okay. So now, and this is the expectation here is that you do write this limit each time. Instead of f of x plus h, it's all of this. So we're gonna grab that.
You like reorder it so that it's like in the
Not because you're, well, I'm not going to, because we're going to use it to simplify. I'm not going to suggest doing that.
Wait, why did you put the additional? Oh, because it's the f of x. Okay.
Yeah, minus f of x. So you have, so like my suggestion is to get these, write them out, and then it's a lot of writing, but it will work. So when you distribute this negative, I'm going to do it. Well, I guess I have the advantage of copy and paste here. When you distribute the negative, you get minus 9 plus x squared. Okay, and then I'm going to switch to red pen here for the moment.
And the 9s cancel out.
And the x squareds cancel out.
And then h's.
Well, there's a check here. The check is that all terms in the numerator have an h in them.
Yeah.
And that's key.
Yeah, you get rid of the h on the denominator, the h with the 2x, and then the other h just becomes h.
Yes, so that's this. And then the other day we talked about, like, the very first thing you try with limits is you try putting the number in. Before now, when you put the number as 0 and for h, you're dividing by 0, so you can't do that. But now you can just put in for h and you get minus 2x.
Okay.
And this is your derivative. This is your f prime of x is minus 2x. Mm-hmm. That's not what it's asking for, but that's an important, like, intermediate step for it. Okay, so let's go back to what it's actually asking for. It's asking for the equation of a line. It says tangent line, but it's always the tangent line. So for a line, you need a point and a slope. So the point you can get without calculus. If x equals 2, how do you get the y value? You put that back in for x. You get 9 minus 2 squared, which is 5. So you have your point 2 comma 5. Is that okay?
Yeah.
Okay. The slope you get from the derivative. So see how you have a derivative? This is a derivative function. The slope is the derivative at a point. So it's minus 2 times 2 minus 4, because that was your x value that you're given. You're given x value.
So is that like a formula? But that's not the normal slope formula.
Right, but that we're not done yet. So the equation of the line is y minus y1 equals slope x minus x1.
Yeah.
And so you used calculus to find that the slope is minus 4, but your point is 2 comma 5.
So then you just plug in those points.
Yep, y minus 5 equals minus 4 times x plus 2 minus 2, x minus 2. Y equals minus 4x plus 8, and then you add 5 to both sides, and this becomes minus 4x plus 13. Looks like it's letter B. There are ways to do this without doing all this to get the right answer, but they're not calculus based. They're like looking at the original function, drawing a tangent line and figuring out which one it could be.
Right. Okay.
Because there's really only one that's reasonable after when you see that.
Okay.
All right, four is like, we already did four in some ways. Like four is got all the elements of three in it. So it probably should have been done first. My mistake on that. Four gives you a function and it asks you to do all these things. So first thing is to find f of 3. That just is putting 3 in for x. So that's 2 times 3 minus 3 squared. So that's 6 minus 9. Part B is f of 3 plus h. So that's 2 times 3 plus h minus 3 plus h squared. This requires a little more work. You have to distribute the 2 in, 6 plus 2h minus, and you'll see I'll do this in parentheses until I'm ready to distribute the negative in. It's 9 plus 6h plus h squared. I'll just remind you that a plus b squared is a squared plus 2ab plus b squared. And then now you can distribute in that negative, so you get 6 plus 2h minus 9 minus 6h minus h squared. And you might even want to combine like terms at this point. So you get minus 3, those are combined, minus 4h minus h squared.
Okay.
Let me know when you're caught up there to go to part C.
You just distributed. Okay. Yes, I understand.
Okay, so part C is to find f of 3 plus h minus f of 3, and you already have the pieces to do that. Like we're just grabbing parts from A and B.
Okay.
So f of 3 plus h is this stuff that I just grabbed there. So that's f of 3 plus h minus f of 3 we found from part A. That's minus 3 all over h. Okay, and this can be simplified. So it becomes minus 3 minus 4h minus h squared plus 3 all over h. And you'll see that the 3's cancel. Do that in red.
Yeah.
3's cancel.
And
Both
then
of these have an h in it. Yeah, so you end up getting something much nicer. You get minus 4 minus h. And then part D is asking for the instantaneous rate of change at 3. It's probably good that we're doing this because you may not know how to take the result from part C and apply it here, but it's basically saying h is 0. And it's 0 here. So this becomes
said to find the average. Wait, is everything we've done already the average rate of change?
No, that's very different than this. In this context, it would not ask that. There's the average rate of change and the instantaneous rate of change are two different things. This is like slope or the secant line. This is also slope, but it's tangent. Sorry.
They ever say find the average rate of change of f at x equals 3?
No, because it's good that you're asking that. The reason I said no so quickly is because if you go back to what we said is the average rate of change formula, it requires 2 points.
Oh, okay.
So it can never be asked at a single point.
Okay. Oh, so all you do is plug in 0. Okay.
Yes.
Okay, cool. So I think we can maybe do just like a few of those limit ones. And then he also posted a Math Excel like review that's optional. So maybe we could do a few of those.
Okay.
So I did 1, 2, and 3 on this limit practice. So all the rest are
All the rest.
fair game.
I'd like to do 9 because it's kind of non-obvious.
Okay, and he said 12 is like pretty, like the worst one on there.
Yeah. 12 is not commonly given, but 9 is. So can do that. So the issue here is that when you put 0 in for x, you get square root of 1, which is 1, minus 1 is 0, 0 over 0. That's no good. Go ahead.
Should your first step always be to just try plugging it in?
Yes, for like maybe the first question on the test, but then
Oh, okay.
like I can almost tell
Then they wouldn't do it after
right,
that.
like your first question on the test will probably be just to put the number in. Second question will be factoring it out to cancel. Third will be something like this or something like 2. So like question 3 on this limit, that's like your second question on your exam, maybe question 4, and then 3 is like this one, and then an infinite limit like 8. But anyway, let me yes, that's the answer is yes, but I mean that goes away quickly. So
Yeah.
I call this the non-obvious thing because it truly is until you've seen it, is you multiply the top and bottom by the conjugate. So the square root of x plus 1 over the square root of x plus 1 plus 1. So the conjugate is the same thing, but with instead of that minus operator becomes a plus operator.
Okay.
So the top you're going to foil the top. Okay, so square root of x plus 1 times square root of x plus 1 is just x plus 1. Square root of x plus 1 times square root of x plus 1 is just 1.
Mm-hmm.
Okay. Now, when you do the outer and inner, do you see that those cancel? It's the outer is square root of x plus 1. The inner is minus square root of x plus 1.
Oh yeah, so you don't even need to write them.
Right. And then the last minus 1 times positive 1 is
-1.
Minus 1. And then you do not multiply the bottom, which maybe you will, but it's not necessary. So the top is nice. So the limit as x approaches 0, you get x over x squared x plus 1 plus 1. If you have done this step correctly, you will always cancel numerator and denominator, something in there. And do you see how the x's cancel?
Yeah.
So when the x's cancel, what is left in the numerator?
1.
Yes, great answer. So the limit as x approaches 0, 1 over square root x plus 1 plus 1. And what's the very first strategy that you're always supposed to try?
Plugging in.
Yeah, and now it works. So it's 1 over square root 0 plus 1 plus 1.
Okay. I feel like that's a lot of things to remember, and you don't get like a note card or anything, or like on the calc AP test, they don't even give you like a formula sheet.
Yeah, I know. Gets worse in calculus too. 8's a good one for us to do. Did your instructor give you their blessing on just using a formula, or do you have to actually show division of the top and bottom by the greatest power? Do you remember us talking about that at all the other day?
If like the numerator is bigger than like the power of the denominator.
Yes. Like the answer here is 2, but there's work to get there.
No, that's, I think, because they have the same, you're saying because they have the same power?
Yes.
I think that's fine.
Okay.
I'm pretty sure that's what he just did in class, because yes, that is what we did in class.
Okay.
I wrote that on my notes, so yes. So if they have the same exponent, if they have the same power it's just the leading coefficient of the numerator over the leading of the denominator, right?
Yes.
And then if the denominator is greater than the numerator, what was it again? Is it 0?
If you said the numerator is greater than the denominator.
Yeah.
So that would be like 2x to the 5th over x cubed plus something. This either goes to plus or minus infinity.
And then if it was the reverse, it would be 0.
Yes.
Okay. Yeah. Okay.
Okay. Let's look at 7 next. Is that okay?
Yeah.
Seven is this. Okay. This one is if you had a graph, and I don't know if you're allowed to do this, but if you were able to quickly graph this, you would see that like normally it's up here and down here, but it flips. So it's this, and then it's this. Okay. So can you limit as x approaches 1 from the left is this way. So do you see how from the left you're tracing it goes up here to
from the left means it goes like left to right, right?
Left, that's right.
Okay.
Okay, so this ends up going to positive infinity, but based on the graph. But there is another way, and this is like I think this is what your instructor wants you to do if especially if you're not strong at graphing this.
Yeah, I would not know how to graph that.
What's a number just a little bit to the left of 1? What can you think of that's just a little bit to the left of 1?
0.9, yeah.
Yeah, okay. And what you do is you imagine, okay, -1 over 0.999, however far you want to go out -1, and you evaluate, figure, okay, well, what is this? Well, this is like, it's a negative 0.00001. So what is a negative over a negative? It's positive. 1 over that becomes an infinity.
Oh, okay. So you really don't have to do like any work. It's just like,
yeah, well, if you understand how to like graph it or how to do these things, like it can go pretty quickly. But that's where it's like, I don't know what to tell you, because it's tough. It's really tough. It's easy for me just to sit here and do it, but like you've got to be able to know these things on the exam.
Yeah.
All right. 6 is like 7. 5 would be the next one. Go ahead.
When you would like think about doing like this method, when you see like it's approaching like a 1 and then has like a negative or a positive after it?
Yes. A one-sided limit is almost always done this way, where you pick a number near it.
Okay.
And it's either something 0.999 or something 0.00001.
Okay.
Okay. 5. Do you want to do 5? Because that could be a test question. I mean,
Yeah, let's do it.
It's kind of a standard one you see in this class. All right.
And I think the first 2 on those were just like definitions.
The first one is the sine x over x, and then the other one, you could multiply by the conjugate. I don't know. I don't really know what. Yeah, I don't know. I have to get back to you on 2. I have to look at it. 5. So 5 here, because it's the limit as x approaches 2, when you put 2 and you get 0, 0, you have to say, okay, well, can I use some algebra here? Well, kind of. So the absolute value of x minus 2 equals x minus 2 if x is greater than 2, and then the negative of that when x is less than 2. So you have to know this definition. And that number tells you where the breakpoint is. So like if it was absolute value x minus 4, it would be greater than 4, less than 4, and you have to know to negate it.
Okay.
All right. So now the limit as x approaches 2 from the left, we're using this one right here. Do you follow why that is? Less than 2 is from the left.
How did you like make this piece? This is piecewise, right?
It's a definition. So if it's absolute value x minus a, it's always x minus a for x greater than a, and then this simplifies to a minus x for x less than a.
Okay, so that's just something. Okay.
Yeah, it's something we gotta know.
So then you're using 2 from the negative.
Because we have that equation. That equation right here is minus parentheses x minus 2.
But why would you not use just like 2? Why are you using it only from the left?
We're gonna do it from the right also, and we're gonna see if they're the same.
Oh, I see. Okay.
Yeah. So then this is over x minus 2. So this cancels, and you get the limit as x approaches 2 from the left as -1. So that equals -1.
Okay.
Now from the right, limit as x approaches 2 from the right is x minus 2 over x minus 2. So I'm grabbing this other one, this top one.
1.
Yeah, it just becomes 1. So
So
it's the limit.
if they don't match, it's like does not exist, right?
Exactly. And this is how you have to do it. D&E.
Okay.
Let's look at 11 next. Really don't want to talk about 10. I mean, I would because it's something that doesn't seem to come up. Maybe get an instructor that's pretty wild and wants to do that, but we can, of course, but hopefully. So, okay, so this is the limit as x approaches 1, and just like the previous one, you have to find the limit as x approaches 1 from the left, and then the limit as x approaches 1 from the right, and hopefully they're the same. So here's 1, and here's from the left. What is the y value that it approaches? What is the y value here?
-1. Yeah.
-1. And then from the right's going this way. What is the y value that it approaches?
-1.
-1. So does the limit exist? Yes.
Yeah. So are they trying to trick you with like the closed circle?
Yes. Now, if it asked, maybe your instructor hasn't asked this yet, but is it continuous at x equals 1?
I don't know.
So it is if the following is true. The limit as x approaches 1 from the left equals the limit as x approaches 1 from the right, which is good so far, equals f of 1. And f of 1 is up here. It's well, actually this is -1/2, but
so if it's a closed hole and then like an open hole like under it where the line goes through, it'll always exist at that point.
So it's not, this thing is not continuous here because there's a hole. But if it were filled in, then it is continuous.
But oh, so it's not continuous.
This one is not. Yeah, not.
Oh, okay.
All right. Now I don't really recommend doing 10 and 12. If you really want us to, we can.
Yeah, that's fine. We can
Do you have something else you'd like us to do? You said there was a
yeah, there's the Math Excel. You want me to send you the user name and stuff again, or
let me see if I've got it here from before. I do have it. Yeah, I can just log in and you can navigate where you want me to on that.
Oh, I have not even looked at the questions, so let me see. I mean, maybe we can just start going through with like question 1. No.
Okay. I'm getting now to where I'm entering your login information.
Okay, and it's the, like you have to go to homework and test tabs, and then it's the chapter 2 review.
Don't want that. It's taking me a moment here.
Okay.
If I can't get it on this try, it was redirecting me to like log into it to register in a class, and I don't want to do that.
Oh yeah.
Let me try this one more time. Pearson login. I will just have you share your screen if so last attempt here. Okay, there we go. All right, there it is. All right, so you said homework and tests and chapter 2 review.
Yeah.
It's question 1. Okay, so I think this would be a good time for you to maybe tell me what you when you see it. I'm going to snip it in here. Look over the question here. It says use the limit rules to determine the following limit. How would you how would you start this problem? I guess is probably.
Okay, so you have to factor it, right?
What's the first thing you should always try?
We'll plug in.
Yeah.
Okay, so, and I guess there's no, it's not zeros. Okay, so it'd be 5 times 2 cubed, which is 8, minus 6 times 4, 7. So then 5 times 6 is 40, minus 24 plus 7. So then that's 31, 9.
I got 40
Oh.
minus 24, 16 plus 7, 23.
Oh wait, hold on. I did this wrong because that is a negative 24. Okay. So that's plus. No. Minus 1, 2, 3, 4, 5, 6. Oh, yes. Okay. Minus 17, 23. Yes. Okay.
Okay, would you like me to enter the answers or just move on to the next question?
Oh, you don't need to enter them now. It's fine.
Okay. Yes. It may give you a different question when you look at it, since I'm not entering the answer also. I don't really know. I've seen so many variations on this over the years. I don't know for sure. Okay.
Well,
This is
doesn't.
all right. So how about this one here? What's
okay, so
what do you see?
if you plug in the 3, that would be minus 12, 16 minus 12 is 4, so 2.
Very good.
Okay. I can do these, and then once we get to the more advanced stuff, my brain just kind of stops working.
I think you'll be okay here. Let's get the next one in. Here. All right, use the graph to find the following limits. Okay, so the first one is to find the limit as x approaches 1, and here's 1 from the left. So it's as if you're tracing the curve along here, and you're asking what is the y value there?
Zero.
0. Okay. How about the limit as x approaches 1 from the right? So from the right, what's the y value there?
-3.
-3. Are they the same?
No.
So the limit as x approaches 1 does not exist. What is the output at 1? Where is it? What is the value at 1? It's where's the filled in circle?
0.
0, yeah.
Okay, cool.
All right, so I'm snipping in another question here. All right, so limit as x approaches c. C is 5, so we'll say 5 from the right. 5 from the right. And then it's going to ask later on, limit f of x as x approaches 5 from the left. And so 5 from the right is using this one because that's greater than 5.
Right. Okay.
Okay, and that's like, I think the problem like this, like if you understand it, if it's visually clear, that's how you know that was that question like 2 on the review. You know, it's one or the other, right? But you got to be careful that you know which one it is. This is 5 over 5 plus 1, which is 2. Now from the left, so let me write this. This is from the right, and then this one is from the left. So this is 5 minus 5, which is 0. And
Okay.
they're different. So does the limit as x approaches 5 f of x, does it exist?
No.
It does not exist.
So it exists from the right and the left, but it doesn't exist like
Yes.
together essentially.
Yes. Yep.
Okay.
So think of there's a river here, and you're coming from the land from the west, and I'm coming from the land from the east, but there's no bridge.
There's no bridge. Yeah. Okay.
Yeah.
Gotcha.
All right. All right. Here's another one for us to look at. I skipped a couple because they were kind of the same. I mean, they're worth going through, and we can go through them next time, but it's something
Okay.
slightly different. All right. Limit as x approaches infinity and negative infinity. So this is your function here, and you can actually break it apart. You can say, okay, what's the limit as x approaches infinity sine 5x? And what's the limit as x approaches infinity of 2x? And then divide the results. So do you know either of these values? Do you know what either sine of 5x does at infinity or 2x does at infinity? Do you have any idea on that?
No.
So the graph of 2x, it just goes up forever. So at infinity, it's like infinity because it goes up forever.
Okay.
Sine 5x, it just oscillates.
Oh, okay.
And it's basically bounded from -1 to 1.
So is this something that like I need to learn before the test, like these properties?
I think so, yeah.
Okay. What is this called? Like these?
Well, it's kind of a synthesis of limits at infinity, and then like what does sine do at infinity, and what does like x do at infinity. But what I'm trying to get you to see here is it doesn't really matter what's up top, whether it's -1 or 1, because over infinity, this is 0.
Because you're dividing like something by infinity.
Yes, yes.
What if you were dividing by negative infinity? It would still be 0.
Still be 0. So actually the other one, when it goes to negative infinity, it's the same. Part B is also 0 because it's the same issue here. You get this thing oscillates forever going the other way, and then you're just going down here, which is negative infinity. So it
Right.
works out nice.
So the horizontal asymptotes would be -1, 1, right?
No, the horizontal asymptotes are at 0. Horizontal asymptotes are at y equals 0.
Wait, how is that possible? Because both of those go through.
Let me graph it, and then maybe that'll make it more clear. I don't know or not. Sine 5x over 2x, and let me switch sharing. Let me just snip this in, see if that makes sense. Okay, so I know you don't have this on the exam, but for learning, it's okay because it really does explain what we're trying to do. So do you see how these peaks get lower each time?
Yeah.
And so eventually it just hovers around 0. And same thing over
Don't they
here.
cross the the x-axis, and that's
Yes.
0?
But the asymptote, like the thing that it keeps approaching is 0. Like it's always kind of going. I understand that, like it's not a very clear, because it's at infinity, it's at this
Yeah.
like faraway place. It's like, what does it look like? It's like it's around 0, but really it's always alternating.
Okay.
So, all right, well, that takes us to the end of this lesson. I will send you the notes and the screen recording out shortly. We've got a lesson scheduled for Sunday. And
Sunday at 11, right?
yeah, 11,
Okay.
yeah. And I will see you then.
Okay, perfect. Thank you so much.
You're welcome. Bye now.
Bye.